let's go together over Chapter 14 Practice Part 2. Types of redox reaction. For the first problem, we will need to use the activity series to determine whether each reaction will take place. If a reaction will occur, write the products and balance the equation. If no reaction will occur, write no reaction. Okay, so first of all, you have to remember that we are here in presence of single displacement reaction. The general template of single displacement reaction is as follows. Elemental A plus compound BC forms elemental B plus new compound AC. Okay, so remember that here in this case, A is elemental. Elemental means that it has no charge and an oxidation state of 0. Here we have a compound, cation, anion. Okay, so we have here the cation B plus combined with the, we have the cation and we have the anion. What will be happening is that the elemental A will take the spot of the cation B, so elemental A becomes now cation A, and cation A is associated with the same anion C. But now the cation B became elemental B. So went from the ionic form to the elemental form. Elemental form means that it has an oxidation number of 0. Okay? So let's look at the first reaction. Zinc, elemental zinc, react with cobalt 2 bromide. In order to know if the reaction is actually occurring, we have to compare on the activity series the elemental zinc with the cobalt ion. If on the activity series the elemental zinc is above the cobalt ion, then yes, a reaction will be occurring. And it's a fact, zinc is above cobalt, therefore yes, a reaction occurs. So now that we know that a reaction occurs, we have to predict the products. So what's going to happen? A, which is the zinc, okay, elemental, so no charge, oxidation state of 0, will become the cation A. So what's the cation that the zinc form? It's Zn2 plus. This cation A will now be associated with the anion C. What was the anion C? It was the bromide ion from the cobalt to bromide. Therefore, the new compound formed between A and C, the new ionic compound, is ZnBr2 in a 1:2 ratio. And then the cobalt, so the cation B, was CO2 plus, and this one becomes elemental B. So it just becomes cobalt. And now we can add this in the equation. Therefore, Zn solid plus cobalt 2 bromide aqueous forms B elemental, so cobalt solid, plus the ionic compound zinc bromide in a 1:2 ratio in respect to the charge. Once you have this, you need to check that the equation is balanced. And yes, it's balanced. Therefore, you did a good job. Okay, so let's move this so we can move on to the next reaction. Cobalt plus zinc bromide, is there a reaction? We're going to identify again. Here is the cobalt elemental, and now the cation is the zinc 2 plus combined with the bromide ion, Br minus, in the Bc compound. So what we're going to do is take a look at the activity series and look if the cobalt is above or below the zinc on the activity series. Realize that actually, no, we know that cobalt is below zinc, therefore there will be no reaction. Okay, no reaction. Why? We're going to write it down. Because cobalt solid is below zinc 2 plus in the activity series. You can find this activity series in your textbook. You can find it as well in the useful information that I provided on Canvas. Okay, so I hope this helps. Let's take a look at the next equation. Cobalt solid plus hydrochloric acid. Scheme is that the cobalt is the elemental one. We are in the case of an acid here. Start with H. Remember that acid is a special case of covalent compound. It actually ionizes when placed in water, and therefore when placed in water, we get the H plus cation and the Cl minus chloride ion, okay? In the activity series, we'll need to compare the cobalt and the H plus, and if you look at this on the activity series, you will notice that cobalt is above H. Therefore, here again, yes, a reaction will occur. So what reaction? We have here elemental cobalt. Notice on the activity series, you're told what ions will be formed. And even though cobalt is a variable charge transition metal, in the activity series, you're told that the cation that will be formed by the cobalt will be CO2 plus. This one will be combined with the anion C, which is the chloride ion. And again, we have a 1:2 ratio here. COCl2 is what will be formed. The cation B is in this case H plus. It will become elemental B. Elemental hydrogen, be careful, is H2. Okay, and H2 is in the gas state. You have to remember your 7 diatomic elements. So what we will be forming is cobalt 2 chloride, aqueous, and H2 gas. Then we need to be sure that the equation is balanced. We have 1 cobalt on each side, but we have 2 H's and 2 Cl on the right side. Therefore, we're going to place a 2 in front of HCl for the equation to be balanced. Question 2. Based on the activity series, which of these metals will react with aqueous nickel 2 chloride? So first of all, what is aqueous nickel 2 chloride? Aqueous nickel 2 chloride is the combination of nickel 2, Ni2 plus, and the chloride polydimic ion. Therefore, nickel 2 chloride is NiCl2. Write a balanced molecular equation to describe these reactions. Well, we have to picture that actually here, this is the cation B, and here we have the anion C. And what we're trying to see is if any of these elemental A will react. So remember that in order for A to react with BC, A has to be above the cation B in the activity series. So take a look at your activity series and you will realize that only iron and aluminum are above nickel on the activity series. Okay? Therefore, we are able to write two reactions. One will be when Fe solid react with nickel 2 chloride aqueous. And the second reaction will be aluminum solid react with nickel 2 chloride aqueous. Only these two will react. You will have no reaction with tin, copper, and gold. And R, no reaction, no reaction, and no reaction. Okay? So one more time, this is your A, elemental A, cation B, and ion C. Therefore, in both cases, we'll be forming the elemental B from the cation Ni2+, so we're forming elemental nickel. Nickel is being displaced. And then the cation formed by iron, so iron A will form cation A being Fe2+, you can look on your activity series, and aluminum will form the cation A that will be Al3+. Therefore, for equation 1, we will combine Al3+, for equation 1, we will combine Fe2+ with Cl-, and the compound AC will be in a 1:2 ratio. So we will form FeCl2 aqueous. For reaction 2, we will combine Al3+ this time with Cl-, the anion C, and in a 1:3 ratio, we will form AlCl3 aqueous. Okay, so we have our products, but now we still need two balance, don't forget. One iron, one nickel, two chlorine, this equation's balanced. For the second one, we have 3 chlorine here and 2 here. We're going to double the odds. Now we have 2 aluminum and 6 chlorine on the right side. We're going to place a 3 here to have the 6 chlorine on the left side, and a 2 here to have the 2 aluminum. Placing the 3 in front of nickel chloride, with nickel 2 chloride, now we have 3 nickel, so I need a 3 here as well, and now the equation's balanced. Question 3. Based on the activity series, which of these metals will react with aqueous nitric acid? So again, what's aqueous nitric acid? It's an IC ending, therefore it comes from nitrates, NO3-. It's an acid, H+. So in a 1:1 ratio, nitric acid is HNO3 aqueous, where H is your cation B and NO3- as your anion C. And we're looking if any of these elemental A will react. Remember that these have to be above H+ on the activity series. Take a look at it and notice that only chromium and lead are above H. Therefore, these 3 will not react. So we will be able to write 2 reactions, 1 and 2. The first one where chromium solid react with nitric acid aqueous. The second one where lead solid react with nitric acid aqueous. Elemental A, cation H+, cation B H+, and ion C, NO3-. We know there's a reaction, therefore the elemental chromium will become cation A, and when the chromium undergoes single displacement, it forms chromium 3 plus. And then the lead elemental will become cation A in equation number 2, and it will become Pb 2 plus, lead 2 ion. Therefore, remember that this is here your cation B that will become elemental B. So in both cases, H2 gas is released, and along with H2 gas, the ionic compound formed between the cation A and the anion C will be formed. So here we're going to combine Cr3 plus and NO3 minus in a 1:3 ratio neutral compound. So Cr NO3 3 times aqueous is formed. For the second one, we're going to combine lead 2 with nitrate, and this time in a 1:2 ratio to get a neutral compound, Pb NO3 2 times aqueous will be formed. We can now balance our equation, and we will get, here we have 3 nitrates, here only 1. So we have an odd number here. So we're going to double the odd. So we have now 6 nitrates. So we're going to place a 6 here to have 6 nitrates. And we have 2 chromium. We only have 2 hydrogen here, but 6 on the left side. So by placing a 3 here, I have now 6 on both sides. Second equation, I have 2 hydrogen here and 2 nitrates here. So I need a 2 here to balance the hydrogen and the nitrate. And my equation is balanced. Again, remember that here, this is elemental B, and elemental B is hydrogen, so it's diatomic, okay? And here again, we formed the ionic compound between the cation of A and the anion in the proper ratio to get a neutral compound. Going to the back of the page now, each of these reactions occur slowly with liquid water, but much more quickly if the water is heated to the vapor phase, which is steam. Complete the reactions to show the product form. Okay, so here we're looking at liquid water. So what I want you to remember is that obviously liquid water is H2O, but you can picture liquid water as being HOH, where this is your cation B, H plus, and here is your anion C, OH minus. Okay, obviously when they're combined, they are the same as H2O. So, first reaction, sodium solid in water vapor. We have still, we have to look, and you have in your textbook how the different metal react in presence of water. And you will see that sodium will react with liquid water, water vapor, and acids. Therefore, there's a reaction. Sodium is elemental A, and then I want you to picture H2O as I mentioned before. So what I'm going to do is just remove H2O the way it is here, write it again like this, so you can see that this is B, cation B, and anion C. The reaction occur, and then elemental B is formed, so H2 gas is released. Along with H2 gas, we're going to form the compound between the cation of sodium and the anion C. In a 1-to-1 ratio, we will form NaOH aqueous. Okay, again, here you have your anion, and here you have the cation of A. 1-to-1 ratio in respect to the charge. Don't forget that we still need to balance the equation. There's 2 H's here, 1 sodium and 1 OH. So I need a 2 here to have my 2 orange H's. And now I place a 2 here to have my 2 OH's and a 2 here to balance my sodium. Okay, once you have written your equation, you can take away HOH and replace by H2O, but it's a good trick to balance this reaction. Then zinc solid plus liquid water. So here, this is liquid water. And what I want you to know, if you look in your test books, is that zinc will only react with water vapor, with steam, okay, and acids. But be careful. Zinc will not react with H2O liquid. And you have a table of the reactivities with water and acid in your textbook. Problem 5. Rewrite this equation as a complete ionic equation and as a net ionic equation, then show the oxidation and reduction of reaction. So let's do this. We have here the elemental iron, cation B, and ion C. We're forming the compound between the cation A and the anion C, and elemental B is formed. Still the same, anything in the aqueous state will dissociate. Anything in the solid, gas, or liquid state will remain the same. Therefore, we're going to form SN2 plus aqueous, dissociation of tin 2 chloride, and 2 of the Cl minus, since there's a 2 here. The iron solid will remain the same, and we will form iron 2 aqueous plus, we have as well here 2 chloride ion, and finally, that remain untouched, the tin solid. We have to identify the spectator ions in order to simplify the equation and get the net ionic equation. You will see here that the chloride ion are spectator ions. We're going to take them, remove them, and we will get the net ionic equation. SN2 plus aqueous plus Fe solid gives Fe2 plus aqueous plus Sn solid. Then we're looking for the oxidation and the reduction of reaction. Remember the beginning of the chapter, we talked about oxidation number. Elemental iron and elemental tin get an oxidation number of 0. Here we have monoatomic ions, therefore +2 for tin 2 and +2 for iron 2. So what is happening here? The tin oxidation number increase, therefore, the tin oxidation number decrease from +2 to 0. Therefore, the tin is being reduced, going from SN2 plus aqueous to Sn solid. If I look at the iron now, let's take another color. Iron goes from 0 to +2, so the oxidation number of iron increase, therefore iron is oxidized, going from Fe solid to Fe2 plus aqueous. We're looking to write what is called the Alf reactions. Okay, so we're going to have to show the electrons. Well, to go from the neutral iron to the iron 2 plus, we've lost 2 electrons. So we have to show that 2 electrons have been lost by the iron. And the electrons will be lost, shown lost on the subproduct side. For the reduction, we're going from tin 2 plus to tin neutral. Therefore, tin 2 plus needs to add 2 electrons to become tin neutral. Okay? Remember that the reduction is the reverse of the oxidation. So electrons are lost in the oxidation and gain in the reduction. We can do the same thing for B. So we have here aluminum elemental and copper elemental, and we have 2 compounds in the aqueous state that we will dissociate. So we'll get 2 aluminum solid plus, this is copper 2 sulfate. So we're going to form 3 copper 2 along with 3 sulfate ion. 3 copper solid remain untouched. And now aluminum sulfate, 2 aluminum ion are released, dissociated, along with 3 sulfate ion. We're going to highlight the spectator ions. In this case, the spectator ions are the sulfate ions, since they are the same on each side of the equation. We're going to remove them to write the net ionic equation, and we are left with 2 Al solid plus 3 Cu2 plus gives 3 Cu solid plus 2 Al3 plus. Oxidation number again, elemental aluminum get a 0, elemental copper get a 0, copper 2 plus get plus 2, aluminum 3 plus gets plus 3 as an oxidation number equal to their charge for monoatomic ion. And therefore, we're looking for the oxidation. Aluminum went from 0 to plus 3, so aluminum is oxidized. Aluminum solid gives aluminum aqueous. And on the other hand, copper will be reduced, going from plus 2 to 0. And we're going from 3 Cu2 plus to 3 Cu solid. Oxidation is a loss of electron. Reduction is a gain of electrons. So we're going to add electron here, and we will be losing electrons on this side. So how many electrons are we losing? We have 2 aluminum here, and for each aluminum, 3 electrons are lost, so 6 electrons are lost total here. And for this one, we're going from the copper 2 to the copper. So we're going to need 2 electrons per copper, so 2 times 3, we're going to need 6 electrons here. So here you have the oxidation Alf reaction for aluminum, and reduction Alf reaction for copper. Just remember that these reactions could be simplified, and C would be divided by 2 all the way, give you Al solid gives 3 electrons plus Al3 plus aqueous, and D can be simplified as well. You can divide by 3 this time, and you will get Cu2 plus gives, Cu2 plus 2 electrons gives Cu solid. Okay, I hope it helps. Let me know if you guys have any questions. Thank you.